All right, you guys, so we are still in proving theorems about parallelograms. This is slide 16 on rectangles. And I can understand why they're putting this in. Parallelograms are like the granddaddy of the family. Then you've got rectangles and rhombi that are part of the parallelogram family, and of course squares that are part of the parallelogram family. So I can kind of, reason with them while putting rectangles in this tutorial. All right, so I bet I'm going to click on rectangles and see a rectangle. Yeah, there it is. Okay. All right, so I got a rectangle here. All four angles are 90. Opposite sides are going to be equal to each other, and they're also going to be parallel to each other, just like a parallelogram. All right, so let's see what we've got to do here. Draw diagonals AC and BD on the rectangle. Measure and record the lengths of the diagonals. Okay, so AC and BD. So I'm going to come over here to segment. I'm going to click on AC. And I'm going to click on BD. And remember, anytime you do something to a GeoGebra that's not already done, it turns it gray. So it looks like AC and BD are both 7.21. So the diagonals on a rectangle are equal to each other. So AC, BD, and I said they were both 7.21. All right, done with question number 1. How do the measurements of the diagonals compare? Already called it. They are congruent. They are the same length, you guys. That makes them congruent to each other. Yeah, they equal. Boom. All right, question 3. Move vertices A, B, C to modify the original rectangle. As you change the rectangle, notice what happens to the diagonals. How does this moving of the vertices affect the relationship between the diagonals that you noted in question 2? I'm going to tell you right now, it's not going to change it. I'm going to come over here and click move, and I'm going to click A and B and C, and I'm not going to move. Get out of there. Let me move C. Woo, 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 woo. Move D. Y'all. Look, they're still the same. In this case, now there's both 6.62. So, no change in the relationship. They're going to stay equal. You guys are going to stay congruent. All right. Question 4. Explain how you can prove your observation in question 3 using, oh God, I hate these problems, using a traditional proof. Ugh. All right, you don't need to develop steps of the proof. Yeah, whatever. All right, let's see what I got here. Let's see, I've got 4 triangles. Probably do something with that. I know they bisect each other since it's in the parallelogram family. You know what I can say? I can say that these 2 triangles, the triangle on the left and the triangle on the right, are the same isosceles triangles. I can prove that the top and the bottom triangles are the same isosceles triangles because these are equal to each other. Oh my gosh, there's all different kinds of things I can say with this. I guess you can just kind of, wow, I'm not really sure where to go. So the diagonals bisect each other. Opposite sides are congruent. Diagonals are congruent. So, opposite isosceles triangles can be proven congruent.
Ankles.
Yes, ma'am.
Have you been on the phone?
Alright, so congruent. Congruent. All right, that's just one thing that kind of popped in my head. Probably anywhere near rectangles are parallelograms, but definition. All right, so they said opposite sides. All right, so they kind of went where I went. They went with to 4 little triangles, diagonals of each side. So they kind of went where I went. All right, good. I feel good about that then. All right, so my self-evaluation is 5. All right, so it looks like that's 16 to 20. I think that's going to be the last one if I remember that right. So this was all about parallelograms. So with this rectangle, you got to know that the diagonals are equal to each other. That's the big takeaway from this. All right, you guys, done with this lesson.